Okay, this is lesson 6.4, and you have just done an investigation. You've learned a little bit about the connection between the graphs of parallel lines and perpendicular lines, and then we also made some observations about the equations and how they are related. So now we're going to take a few notes. You have a little space there. We're going to take notes on parallel lines on one side and perpendicular lines on the other side. So the perpendicular line notes are a little bit longer than the parallel line notes. So make sure you leave enough space over there and write small. Not super small, but there's not a lot of space there. Parallel lines are lines that run in the same direction and never cross. Lines that run in the same direction and never cross. They're indicated by matching arrow symbols. And the key is the slopes of parallel lines are the same or are equal. So if we're going to draw a set of parallel lines, we just draw two lines that go the same direction, making sure they look like they'll never cross. And it really doesn't matter what they look like, because as long as they have this matching arrow symbol, that tells us that those lines are parallel. Okay, to the right of that you have some space to take notes on perpendicular lines. Perpendicular lines. These are lines that intersect at right angles. Indicated by a small box in the 90-degree angle. Okay? So our little diagram. You have a little few more notes here, so make sure that you are leaving space. So there's our diagram, and we need to make sure that we just put the box in one of the corners. Now, in this situation, when straight lines intersect, you only need to show that one of them is 90 degrees. Because if one of them is, they all are. Okay? Because we know that supplementary angles add up to 180, so that means if this is 90, this has to be 90. If this is 90, this has to be 90. If this is 90, this has to be 90. Okay? Good. The other note that we have here is that the slopes of perpendicular lines, how do they relate to each other again? They are negative reciprocals. Negative reciprocals. And go ahead and underline that word. And I'm going to write what that means. These are two numbers whose product is -1. So that means that they are two numbers that when you multiply them together, you get the result of -1. Okay? So the slopes, we're talking about slopes here. So basically what you would be doing is you'd be taking the slope of the first line, and if you multiplied it by the slope of the second line, you would get -1.
All the time.
Okay? If that is true, then they are perpendicular. Now, typically, you'll be given the slope of one of the lines, and you'll be asked what slope is perpendicular to this slope. So that would look something like this. Let's say you had the slope 2 over 3 was m1, and you don't know what m2 is. You don't know what the slope of the next line is, but the question asks you to find the slope of the line that would be perpendicular. Well, we need to just take the negative reciprocal. So watch what happens. What's the negative reciprocal of 2 over 3? Negative 3 over 2. So watch what happens. If we have negative 3 over 2, and we do top times top, we get negative 6. Bottom times bottom is 6. That reduces to negative 1. Therefore, these slopes are perpendicular. Okay? Now, you need to know this. This is the rule. You need to know that this is what causes lines to be perpendicular. But for all practical purposes, once you get good at it and used to it, you can just say, oh, if m1 is 2 over 3, then m2 must be negative 3 over 2. You'll know that. Okay? If m1 is 1 over 4, then don't say it out loud. What do you think the slope of the second line needs to be in order to have a perpendicular line situation?
4 over 1.
Close?
Oh, sorry. Negative 4 over 1.
Negative 4 over 1, which reduces to negative 4. Okay, these guys are perpendicular. These guys are perpendicular. Okay? So no matter what slope you get, you can quickly and easily find the slope of the line that's perpendicular just by doing a negative reciprocal. Well, your homework is examples, and we're going to do a couple of examples now as well. Okay? So from now on, you need to remember what the word negative reciprocal means. You need to know that that relates to perpendicular lines. So here we go. Example, slopes of parallel and perpendicular lines. So we get one example of each. In A, it says the equation of a line is y equals 3x minus 4. Give the slope of a parallel line. We're going to add another question to that, but what's the slope of any line that's parallel to this line?
3x minus 6.
Sorry, just the slope. So we're looking at, we've got y equals mx plus b, where m is the slope.
3.
So m equals 3. Okay? Everyone, go ahead and write 3 equations in the form y equals mx plus b that are parallel to this line. And remember, all that means is that they have a slope of 3. So go ahead and write the equation of 3 lines that have a slope of 3. Okay, I'm going to ask for every single person to give me one of their lines, starting with Jenna.
M equals 3x.
Y equals
3x plus
3x plus 2. Good.
2. Y equals 3x minus 7. Oh, I had those exact ones.
I have those exact.
Sammy?
Y equals, wait, where was I? 4x plus 6.
Double check. Does that have the same slope as this one, and this one, and this one, and this one? You did have to make your own. Your own that's parallel to the line that was given.
Oh.
Okay, so that one's not going to work. Emily?
Y equals 3x plus 5.
Jacob?
Y equals 3x minus 4.
Maddie?
Y equals 3x minus 7.
Jaden?
Y equals 3x plus 2,789,000.
You're the kind of guy.
Well, it's true, it can do that.
Ronnie?
Y equals 3x minus 100.
Alright. They're all parallel lines. Okay, they all cross the y-axis at different places, except for these two. They're actually just the exact same line. Okay? But they're all parallel. They all have a slope of 3. They all look kind of like that. Okay? Make sense? I'm going to clear this one. We're going to move on to B. Example B says the equation of a line is y equals 3 over 5x plus 2. Give the slope of a perpendicular line. Don't call it out. What has to be true about the slope of a perpendicular line? It's going to be a negative reciprocal. Okay, everyone put the negative reciprocal in your head. Put up your hand if you'd like to share. Go for it, Emily.
Negative 5 over
Negative 5 over 3.
So that's what it is.
Okay?
Plus 2.
So now, let me explain this for a second. So basically, if you had a chart, if you had your grid, okay, I'm going to ignore the y-intercept right now. I'll use it for this one. But let's say we had it going through 2, and this is rise over run, right? So it's going to rise 3, run 5. So rise 3, run 5. Rise 3, run 5. And this is just kind of an estimate. But this is approximately what that first blue line will look like. Now, if I start anywhere in the whole world, doesn't matter where I start, okay? I'm just going to start, I'll start right here, okay? Now look at this one. I'm going to rise negative 5, so I'm going to go down 5, and then I'm going to run to the right 3. So I've got rise over run, okay? So I'm going to go down 5 over 3. Watch what happens. Down 5 over 3. Down 5 over 3. Now, mine is not perfect, but you can start to see
A 90-degree angle. Wow.
they meet at a 90-degree angle. Okay? If you've drawn a line with the opposite reciprocal or negative reciprocal slope, it will cross at a 90-degree angle, no matter where you start. I could have started over here, and I could have gone down 5 over 3, down 5 over 3, and drawn my line, and you get the same situation.
They would have been parallel
Okay.
and perpendicular.
Now these guys are actually parallel because they both have this slope, but they're both perpendicular to the line with this slope. Okay?
So,
Go ahead and write the equation of 3 lines that are perpendicular to this line. Okay? Perpendicular to the blue line.
Would it matter if we had? Does the 2 matter at all?
Does the 2 matter at all?
no.
No.
What? No.
We're talking about slopes. Okay? Go ahead and write 3 lines that have the negative reciprocal slope. Okay, we're going to do the same exercise. Jacob, give me one of your lines.
M equals.
Sorry, y equals?
Oh, sorry. Y equals 5 over 3, or negative 5 over 3.
Good, that negative is incredibly important.
Plus 28.
Negative 5 over 3x plus 28. Good. Next, Maddie.
I don't get what we did.
That's okay. Keep thinking about it as we go along. Jaden?
Y equals negative 5 over 3x plus 15.
Ronnie?
Y equals negative 6 over 10 plus 3. 6x.
Does that, we need to have the exact same slope
Oh.
as these guys.
Y
The
equals
opposite reciprocal of this. So the slope
Y
is going to be this.
equals okay, x plus 10.
Good. Jenna?
Y equals negative 5 over 3x minus 9.
Olivia?
Y equals negative 5 over 3x plus 4.
Sam?
Y equals negative 5 over 3x plus 12.
Emily?
Y equals negative 5 over 3x minus 17.
Maddie?
Y equals negative 5 over 3x plus 15.
Okay, what is true about all of these lines?
Perpendicular.
They're all
They're
perpendicular.
parallel.
To each other.
They're parallel.
They're parallel to each other.
To each other, they're parallel.
They're perpendicular to that one.
To this guy, they're perpendicular. Okay? Your practice problems are in the book. Okay? You need to complete them in your practice problem notebook, not directly on the page. If you are not done yesterday's, then start that first.
Are we allowed to use Desmos?